Hello students, this video is for honors today, and honors we learned how to write double replacement reactions, and today what you're going to learn how to do is to predict whether or not they happen. Now if you remember from yesterday's lesson, we said a double replacement reaction will happen in three ways. It will happen if a solid forms. It will happen if a molecular compound forms. Now remember, a molecular compound is anything covalently bonded, and we remember from January that all covalent compounds contain nonmetals. So for example, H2O. If you see H2O forming, that's a liquid, that's a molecular compound. So if a molecular compound forms when they exchange or the wife swap happens, then you have a double replacement reaction. And in the third instance, a double replacement reaction will happen if a gas forms. Now, if you're foundations and you're watching this, you can keep watching it, but this content will only be on a test for our honors component. Okay, now let's go back. If a solid forms, you have to know whether or not something will make a precipitate. If it makes a precipitate, it forms a solid, and we've seen this in the lab. It either forms a solid and you can visibly see it. So if it makes a precipitate, that means it's insoluble. So in order for a solid to form, something must be insoluble and form a precipitate. And I'm going to link some videos for you to see these reactions happening, and when we get back to school, hopefully soon, we will do these in the lab. Okay, now there's a series of solubility rules. I'm also putting up a video that a high school girl made, and she came up with a very fun way to learn whether or not something is soluble or insoluble, and she has a phrase that says Castro bear. I'll put that video in the link. I'll upload that one for you so that you can watch that. But for now, I've uploaded PowerPoint 11.3 for my honors classes. And if you go to slide 29 on PowerPoint 11.3, you can see what's soluble and what's insoluble. You will be allowed this chart on your next test. In future chemistry classes, your teacher will probably require you to memorize the solubility rules. In AP, I require my students to memorize the solubility rules. Okay, so let's practice this first scenario, okay? If I was given sodium carbonate and an aqueous solution of that, and I was told to mix it with barium nitrate, the question would be, would this make a precipitate, and would the reaction thus go to completion? Because if a precipitate doesn't form, a molecular compound doesn't form, or a gas doesn't form, then you're just mixing solutions. Nothing's going to happen. The ions aren't going to exchange. So this is our wife swap problem. So we're going to take the sodium and the barium. These two guys are going to trade places. So we're going to trade places. We've got to keep our wits about us. We've got to balance our charges. So barium, carbonate, let me see if that compound is correct, +2, -2, oops, it works. Okay, so I can just leave that as is. Plus, now sodium. Sodium only has a +1 charge, and nitrate only has a -1 charge, so it's going to form NaNO3. Okay, so those are my two compounds. We're going to balance this thing at the end, but let's now look at our table on slide 29. So you can open up the PowerPoint, look at the table on slide 29. At the very bottom it says carbonates, phosphates, chromates, sulfides, and hydroxides. Most are insoluble. Here's a carbonate. So this is probably insoluble. If it's insoluble, it makes a precipitate, so this would be a solid. And then let's look at nitrates. Nitrates are mostly soluble. Soluble means it stays in solution and it does not form a precipitate. So this reaction fits with scenario number 1. So this reaction happens. So that's an example of the reaction that forms a solid. Our other word for a solid is a precipitate, and because it forms a solid, we know that the reaction occurs. Now we need to quickly balance this thing. I want you to pause the video, try and balance it on your own. All right. Hopefully you pause the video, try to balance it on your own. I'm going to put a 2 here, and 2Na, 2Na, and I believe we are finished. Looked like it was going to be difficult, and it was an easy one, right? Okay, let's try another one. Let's try another one. We have in our next reaction ammonium chloride. These are all aqueous solutions. Sometimes I forget to write these in. Plus lead nitrate. Now, if they wrote lead nitrate twice, remember nitrate is -1. There's 2 of them. That means lead has to be +2. So lead would be lead. This is lead 2 nitrate. Great thing about chemistry is you always have to remember the previous days, right? Okay, now we're going to see if this reaction occurs. I'm going to get rid of all of this. You should have your solubility table open, slide 29 from PowerPoint 11.3. And we're going to see if these 2 guys trade places. So you're going to take the positive ion, in this case it's the ammonium ion and the lead 2 ion, and you're going to see if they trade places. So we're going to go ahead and trade them and then see if one of them happens to be soluble. Okay, so here we go. We trade places and we have lead chloride. Now lead chloride, I've got to write the right formula. This was +2. Chloride is -1. Oh, so I'm going to have to put a 2 here to balance the charges. Yep, okay. Keeping my wits about me, not forgetting the things I've learned in the past. Okay, and then ammonium is going to be with nitrate. And if you remember from the polyatomics I made you remember, ammonium is NH4+, nitrate is NO3-, so the 2, you can just put them straight together. NH4, NO3. We'll balance this thing in a minute. No sense in balancing it if the reaction doesn't happen, right? Okay, so now we're going to go through and we're going to look at our solubility table. So let's look at this one first. If we look at chlorides, on your solubility table, slide 29, 1, 2, 3, 4 down, it says chloride salts. It says soluble, but then it has some exceptions. The exceptions are silver, mercury, and lead. Okay, so that means lead chloride is insoluble, which means it forms a precipitate, which means it makes a solid. And this guy has a nitrate, and most nitrates are insoluble, so that's going to be aqueous. So yes, this reaction happens according to rule number 1. All right, I want you to pause the video now, and I want you to try and balance this thing. Okay, pause the video. All right. Okay, hopefully you're back. You balanced it. I'm going to put a 2 here. And I'm going to put a 2 here, and I believe we are balanced. Yes, we are. Okay, once again, it looked like it was going to be a nightmare, but it was not. Okay, we're going to do one more practice of this one. Now, what I'm going to do is I'm just going to write down the question. This is iron 3 nitrate plus sodium hydroxide. Sodium hydroxide is the key ingredient in Drano. Now, how do I know that this guy right here is iron 3 nitrate? Well, nitrate is -1. There's 3 of them, so this has to be +3. So your iron in this one is going to be +3. So I'm going to write this down to help you. Now, I want you to pause the video and I want you to try and finish this one on your own. Swap the ions, decide if either of them are soluble. If one of them is insoluble, it forms a solid, and therefore the reaction occurs. Okay, so pause the video, try and finish it on your own. Okay, I'm back. So hopefully you did this on your own. I'm going to exchange these 2 ions. And when I exchange these 2 ions, I land up with iron, still iron 3, hydroxide. Oh dear, oh negative, it's hydroxide. This is +3, so I need 3 of them. Okay, plus sodium nitrate. Sodium is +1, nitrate is -1. Here we go. Okay, let me get rid of all my mess. Hopefully you got that. Now you have to decide, is this one going to be insoluble, or is this one, or neither? If neither are, then the reaction doesn't happen. Neither of these are molecular compounds. Neither of these form a gas. So one of them better be insoluble, otherwise the reaction doesn't happen. So now go back to your table on slide 29 and let's find hydroxides. It says hydroxides, most are insoluble. So this one forms a solid, and there's nitrate again, and we know that those are soluble. So this reaction does occur. Now, we've got one last thing to do. We've got to balance the baby. Okay, so let's look. On this side right here, I have 3 hydroxides. I'm going to throw a 3 right there. On this side right here, I have 3 nitrates, and over here I only have 1, so I'm going to throw a 3 right there. And I believe it's balanced. Now, if you are unable to do that one on your own, I want you to back up and I want you to try it again all on your own and then fast forward and see if you get the answer. We're going to stop right there, and in the next video I'll give you examples of reactions that form a molecular compound and reactions that form a gas. Remember, on a test you'll be given the solubility table like slide 29. So all you have to do is remember how to write your formulas, switch the ions, and this is just one more step in our incremental learning in chemistry. Okay, that's it for now.